This workshop focuses on talks between different fields because making robots sense like nature thus needs ideas from biology, sensor design, and robotics together. This is important because robots now work in messy and changing places like dirty water or cluttered areas, where normal sensors like cameras do not work well. Biological ideas help because nature's sensors are tough and work well in hard places. For example, robots with artificial fish little eyes can feel water movement in the dark, so they don't hit things. Robots with artificial whiskers can figure out what an object is like, its shape and textures, even in total darkness.
The first step is that we should have to use some tools to capture the movements or locomotion of the animals to get some intelligence from the animal itself. The second step is learning these techniques or some specified movements, and we can get some new ideas of how to fabricate bioinspired robotics. And thirdly, according to this information, we can get some new ideas for the whole system. I think this is free for all of the engineers and also the researchers doing some interdisciplinary research. Probably the biologists and the mechanical engineers, researchers focusing on building the new type of the robots. I think the first word to describe this part is about the interdisciplinary research. The interdisciplinary combines a lot of disciplines. The second is innovation, and it is innovative. We find some new ideas, and by talking to each other, we can generate some new ideas. The third is open-minded. We use some new techniques or some new technologies to solve one problem from different perspectives of ideas. This is what we are focusing on.
The workshop has great parts, talks from experts, poster shows, and new research presentations. We focus on turning nature's ideas into real and useful robot sensors. People from different fields will meet and share ideas. Professor Ajay Kotpuri from University of Groningen specializes in miniature CDS sensors inspired by nature, enabling robots to detect air or water movements for better environmental perception. And Professor Hiroto Tanaka from Institute of Science Tokyo explores wind sensing via flexible flapping wings, drawing from biological mechanisms to enhance robotic flight performance. There are many cool ways nature senses things that we can use for robots, and biologists and engineers can work together to translate these ideas to real life, like detecting the environment or rescuing people.
Using tools and using combined tools, not just one tool to observe the behavior, and using combined tools to solve the problems, using combined tools to have new discoveries or build some new theoretical or experimental framework.
Welcome to Hangzhou, share your work and make robots sense the world like nature does. Join us.
Welcome to our workshop, and be open-minded and be interdisciplinary.